So we are going to begin with the section 1.1 of pre-calculus. So that's, I would say, the beginning of the formal subject of pre-calculus. So today we are going to talk about some definitions and then learn the basics of how to plot points in a Cartesian plane. What's the distance formula? How do you compute distance between any two given points in a plane? What's the midpoint formula and how to use it? Again, plotting graphs, because once you know how to plot points, then you eventually learn how to plot graphs of given equations or functions. And then one more characteristics of functions or graphs is finding intercepts with the definition of intercepts. So let's just get into it. So these are the few definitions we need to be very clear about in order to understand the graphing and everything about plotting points in a Cartesian plane. So the very first definition is itself of Cartesian plane. So it's a plane used to visualize the relationship between two variables. So it's actually given by the name of the mathematician Descartes. So under his name, we get Cartesian plane, but specifically, if you do not want to use the term Cartesian plane, we can simply call it XY plane or 2D plane, two-dimensional plane, or simply just a plane. We understand by default we are working in two variables, so it's a plane. We start using the term space when we are using three variables. So as long as we are with the two variables, one independent, one dependent, we are in a two-dimensional space or just a plane. So why do we use Cartesian plane? Because we want to visualize how x and y are connected with each other, what's their relationship with each other. And then another definition we have is of ordered pair. That's a very important term in real numbers, or I would say pre-calculus, calculus, algebra, whatever you want to call it. In mathematics in general, it's a very important term to understand. What do you mean by an ordered pair? So it's a pair of real numbers in which order is specified. That means if I give you two real numbers and the order of them changes, results into change in something. If the change in order results into change in something, that means the order matters. The order has to be specific. So that's where the term ordered pair arises too. So 2, 3 is different than 3, 2. That's what we mean by an ordered pair. And this is a standard conventional notation of an ordered pair. You enclose them in the round brackets. The first coordinate is always the x value. The second coordinate is always the y value. Another term used for the ordered pair is coordinate. Coordinates of the point. It basically refers to location of points in a plane, like where exactly you are in a plane, how do you know that location? So it's a way of, labeling their address through the ordered pairs. And be very careful, it has a notation similar to the intervals on real line. Remember we talked about intervals a, b. The notation is same, but the meaning is completely different. Intervals on real line were defined like this, that you are just on one line and there's one value A, there's another value B, and you're going from A to B. So interval means all the real numbers between A and B, not including A and B. But here, this 2, 3 does not mean the interval between 2 and 3 or the real numbers between 2 and 3. It refers to something else. We'll talk about what do we mean by this or what does it refers to in a plane, but it's different than an interval. So you have to understand based on the context in which you are using it. Based on that, you have to make the decision whether it's an interval or whether it's an ordered pair. And now x is called the first component. A very specific name for that is abscissa, and y is called the second component. Again, a very specific term used for the second component is ordinate. Collectively, abscissa and ordinate are known as coordinates of the point. So even though you don't want to know these terms or don't want to use them often, it's fine. You can collectively just call them coordinates of the point. Now the Cartesian plane is also called coordinate plane or XY plane, as I just already told you. So done with these terms, move ahead. Another term we need to be clear about is what do we mean by quadrants in a plane. So this is how an XY plane or a Cartesian plane looks like. It's formed from two lines, one horizontal, one vertical, and this is known as x-axis. Horizontal line is x-axis, vertical line is y-axis, and in the middle they are intersecting at a point called origin, which is 0, 0. So that's the point where everything originates. That means if you're measuring distances, if you're labeling the points, it's all with reference to that specific point, origin, 0, 0. And these arrow indicates the progression of the x numbers. So this means if you're going towards this direction, so x values are increasing, means your distance from the origin is increasing if you're going right. And similarly, if you're going left, your distance from origin is also decreasing, but they are negative values in a negative sense. So specifically, or you can say they are further, x and y axis further are partitioned or categorized into positive x-axis and negative x-axis. So this part is the positive x-axis, and this part, this axis, is the negative x-axis. So when we say a point lies on negative x-axis, so we are very much clear that it lies on left of the origin on the x-axis. And similarly, the y-axis being fragmented into two different parts. This is the positive y-axis, this part is the negative y-axis. So collectively it's a y-axis, but you know the positive y's are above the origin, or above the x-axis we have positive y, and below the x-axis we have negative y. That's what is going on. So now these are 4 lines. Now initially you were looking at them as 2 lines, but now if you look at them as 4 pair of lines or 4 number of lines, then they divide the entire entire plane in 4 parts. Part number 1, part number 2, part number 3, part number 4. These are known as quadrants. Quad means 4. It's like 1/4 of the entire plane. So 4 equal parts of Cartesian plane, they are known as quadrants. And conventionally we do have a labeling for that as well. Like it's not like a random thing that you can call whichever quadrant 1 or whichever 2, 3 and 4. They are mathematically uniquely defined for you. This is always quadrant 1, this is 2, this is 3, and this is 4. It's default, it's not going to change. So that's what is written here: quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Now what's the characteristic of quadrant 1? The characteristic of quadrant 1 is plus plus. Now what do you mean by plus plus? So this plus plus actually refers to a coordinate in xy plane, and specifically when the point, any of the point is in quadrant 1, is x value as well as y values both are positive. Because you can see this is positive x-axis, this is positive y-axis, so anything which falls into the intersection of them is a positive point, means both x and y are positive in the first quadrant. In quadrant 2, now quadrant 2 is here, so x is negative but y is positive, so it's a minus plus. And in quadrant 3, both are negative, x is negative and y is negative. And in quadrant 4, we have x positive but y negative, because this is where it is formed. So that's the specification of these, like why they are labeled like this. You don't need to memorize this, but automatically you will remember this once you are playing with numbers or points in a plane. And this is how any general point in a plane is indicated. It's labeled with a point P. You can use any notation, and these are the coordinates A, B. Now let's understand the meaning of A, B. So how do you decide that this point is A, B, or how do you decide this point is 3, 4? Okay, let's understand from 3, 4 first. 3, 4 means the distance of this point from the origin on the x-axis is 3 units, and the distance of this point from the origin along the y-axis is 4 units. In other words, In order to reach this point, you have to go 3 steps horizontally away from the x-axis in the positive direction because it's +3, and then since it's +4, so you have to go up 4 units. So go right 3 units and go up 4 units, you will reach this point. And now what do we mean by 1 unit? That's something you can choose on your own, depending on the space and depending upon the magnitudes of the numbers you're working with. You have to define your 1 unit as a standard unit. So keep the scale uniform. So this is my 1 unit on x-axis. So 1, 2, 3 takes me here, and then from here I want to go 4 steps up. So 1, 2, 3, and 4. This is where I reach. So 3, 4, the meaning of that is 3 units on x-axis, 4 units on y-axis. So A, B means what? So A units away from origin traveled horizontally towards the right, and B units above on the y-axis. So this distance is A units and this distance is B units. So if you understand this, you understand how the points are labeled, how the quadrants are defined, what is x-axis, what is y-axis, and so and so. Now let's move ahead to understand how do you graph points in a plane. So it's a simple exercise. So you are given some points, you have to just locate them where they are in the plane. So just draw the plane, draw the 2 lines, and then look at the magnitudes. So they are like closer to 3, 4. So you can choose a decent 1 unit. So this is 1, 2, 3, 4. This is -1, -2, -3, -4. And similarly on y-axis, this is 1 unit, 2 unit, 3 units, 4 unit. This is -1, -2, -3, and -4. Now look at all the points. The first point is 3, 1. So that means 3, 1 means 3 units on x-axis and then 1 unit on y-axis. So this is where you would reach. So this is the point A, 3, 1. B is -2, 4. So -2x is -2, y is +4. So this is where you meet. -2, 4 units up. This is the point B. C is -3, -4. So C is -3 means you come here and then 4 units down. So this is where you reach. This is how you label. -3, -4. D is 2, -3. So 2, -3. This is where you are at. And then E is -3, 0. So -3, that means here you are, while y is 0 means you do not move vertically up or down, you stay on the x-axis. So that's the point E, -3, 0. So these are the points which were given to you and you have now marked them into the plane at positions. They're adequate positions. So that's what the question asks us to do. So this is the first step of understanding Cartesian plane and plotting graphs in future. You should be able to mark the points accurately. So A is in quadrant 1, B is in quadrant 2, C is in quadrant 3, D is in quadrant 4, while the point E is not exactly in any of the quadrants. It's actually on the x-axis. More specifically, you can say it's on negative x-axis because the x is negative, right? So there could be points which are in the quadrant, which are on the axis, positive, negative x-axis, positive, negative y-axis. They could be anywhere. And I want you to observe one more thing specifically about the point E, -3, 0. So y coordinate equals to 0 means what? Y equals to 0 means the point is on the x-axis. So anywhere, whenever you are given or you're working with a point whose y coordinate is 0, so it should immediately come to your mind that, okay, that point is exactly lying on the y-axis. Because y equals to 0 is acting like the ground floor. You're not going up, you're not going down, you just stay there on the x-axis. So that's something you can understand from just by looking at the point that where exactly this point is. It is on the x-axis. And similarly, if I give you another point 0, 4, this means this is a point where x is 0, y could be anything. Specifically for this, y equals to 4. So if you mark this point, let's call this point f. So this is the point f, 0, 4. So where is this point? This is on y-axis. So x equals to 0 would always mean y-axis, and y equals to 0 would always mean x-axis. So that gives you another important result to understand. Later on, we will talk about equations of lines in a plane, and we have two default lines in a plane, our x-axis and y-axis. So for them, we just know the equations. So equation of x-axis is y equals to 0, and equation of y-axis is x equals to 0, because that's the characteristic of any point lying on those axes. So that generates the equations of them. So remember this for future, that what are the respective equations for x-axis and y-axis. All this is coming from observation. So we just did this example. Here are those points which we just already labeled. Try this yourself. So I'm leaving this for you to try it on your own. You can pause the video, take your time, mark them in your plane, and then come back and verify the answers. So I'm going to draw the answer for you. I'm going to mark them for you. So say if this is like 1, 2, 3, 4, and 5, this is -1, -2, -3, -4, -5. Then you have 1, 2, 3, 4, 5, and again -1, -2, -3, -4, -5. So P is -2, 2. So -2, 2, that's where you have P. 4, 0, that's the point Q. 5, -3, so that's the point R. 0, -3, that's the point S. And -2, 1/2, positive 1/2, so somewhere here, because this will correspond to half, so roughly somewhere here, this is T. So if you're drawing on graph paper, it's going to be super accurate. If you're drawing on a white paper, so it's obviously going to be a little approximate, but it should not be that bad that we are not able to look at the nature or their relationship with each other. So it's fine to have little imperfections, but not too much. So that's the answer for this. And we just learned how to graph points in our XY plane. And now the next thing we want to learn is how to find the distance between 2 points in a plane. Now for this, you have to recall something about how will you compute the distance between any points on a line, right? And to understand this, you can imagine yourself that you're in a room and there is one person on one side of the room, one corner, another person sitting on the other corner. How will you measure the distance between them, right? Without actually using any measuring tape, what's the mathematical way of computing the distance? So give it a try, pause the video, do some brainstorming, and think about how would you actually compute the distance. So here we have the answer. The Pythagorean theorem from trigonometry helps us in getting the answer. Because suppose one person was here, another person was here in the room, diagonally opposite to each other. So you could actually know the dimensions of the room, that how far that person is from this corner and how far this person is from this corner. You could know these distances, and then by using Pythagorean theorem, a square plus b square equals to c square, you would have got your answer, which is C. So this theorem helps us in finding the distance, and this forms the basis of a general distance formula. It's not like in the questions we'll be directly using this, but we'll be using a formula which comes from Pythagorean theorem. So I'm going to share that formula with you. So here we have P. Suppose a general point P anywhere in the plane with the coordinates x1, comma, y1. And we have another point Q anywhere in the plane with coordinates x2, comma, y2. And you are interested in finding the distance between P and Q. That's how P and Q distance is measured. So in order to measure this, you can form a right angle triangle by having this point into the picture and join P and S, join S and Q. And if you're able to measure these distances and then using Pythagorean theorem, you will be able to get the formula for the distance. It's very easy to derive. I can show you that. So P's coordinates are x1, y1, Q coordinates are x2, y2. So how much is this? Because they could be anywhere on the x level, but when you are measuring the vertical distance between them, you are essentially subtracting the y values, right? So x values do not play a role when you're talking about measuring distance between S and P, because they're on the same x value. See, this is x1, this is x1. They're on the same x value, but they are on the different heights. So it's simply y2 minus y1. And just to be mathematically accurate, since the distance cannot be negative, so we have used an absolute value here, because in this situation you can clearly see y2 is greater than y1, so it's fine even if you don't use the absolute value. But we are trying to generate a general formula which will work for all possible combinations, so it's better to enclose them into absolute value. The only reason for this is because we know that it could be negative, so you could generate that with the absolute value sign, but you could make that positive because distances cannot be negative, right? So distance between the point S and point P is y2 minus y1, absolute value. On the similar lines, I hope you can understand what's the distance between the point S and Q. They are sitting on the same y level, but they are different x values. So the difference between x coordinates will give you the distance between them. So it's x2, x1. So subtract them, you will get this distance. And now the Pythagorean theorem tells you that just d square is ps square plus sq square, right? So y2 minus y1 square plus x2 minus x1 square, that's d square. But our goal is not to find d square, our goal is to find d. So d is square root of this. Now eventually you notice that you are squaring these distances, y2 minus y1 and x2 minus x1. So even if you do not take the absolute value, it doesn't really matter. So even if they were negative, because eventually they are something to be squared, so it doesn't really matter whether you include the absolute value or not. What I'm trying to say, even if you do y2 minus y1 or you do y1 minus y2, it won't change anything, because eventually everything is going to be squared. It will be turning into a positive quantity, and then d will be the distance. So that's the formal formula we have for the distance between any 2 points in a plane. You just need to know their coordinates. So if one point coordinates is x1, comma y1, another point's coordinate is x2, comma y2. So dpq, that's the notation for denoting distance between p and q, square root of x2 minus x1 square plus y2 minus y1 square. An easier way to remember this is, you just remember it like, okay, difference of x values square plus difference of y values square, and then all together inside the square root. That's the distance formula for us. Now let's use it on an example. So we are given 2 points here, P and Q, and you're supposed to find distance between them using the distance formula. So P is negative 2, comma 5, Q is 3, comma negative 4. So distance between P and Q is square root of x1 minus x2 square plus y1 minus y2 square. Now what is x1, x2, what is y1, y2? So you can compare the given coordinates with x1, y1, and the other point is x2, comma y2. So this gives you, how do you compare now? So compare the first coordinate with the first coordinate, compare the second coordinate with the second coordinate. So x1 is negative 2, y1 is 5, x2 is 3, and y2 is negative 4. And once you have that, you just plug everything in, you'll get the answer. So x1 is negative 2 minus x2, that's 3. y1 is 5, y2 is negative 4, square of that. Now negative 2, negative 3, that's negative 5. Square of that is positive 25. And this is 5 plus 4, because minus minus becomes plus, 5 plus 4 becomes 9. 9 squared is 81. And so what do you get? 6,106 units. That's the distance between the points P and Q. If you want to simplify, you can simplify that. Otherwise, this is fine as an answer. Yeah, so here we have the simplification. It's roughly 10.3 units. So if the question does not state anything that how many decimal places you have to include at least 2 to 3 places and then doing the round off. But otherwise, you could leave it at the exact number as well if you don't want to do anything with it. Just leave it here. So here's another example for you to try. So I'll suggest you pause the video and then try this yourself and then come back and verify the answer. So I'm going to verify this for you. So distance here is difference of x values, difference of y values squared. So that's 1 square, that's 1 square, that's square root of 2 units. That's the distance. And now we are going to talk about another formula, how to compute midpoint between any 2 points. So for this, we need to recall how we used to compute midpoints on any 2 points on a real line. So think about it. If I give you any 2 points on real lines, say one of the point is 0 and one of the point is 2. What's the midpoint? Take a pause, think about it. What's the midpoint between 0 and 2 on a real line? Midpoint is obviously 1. How do you get that mathematically? 0 plus 2 divide by 2. So the left hand point, the right hand point, add them, divide by 2, you get the midpoint. And similarly, if I ask you, there's a point negative 1 and then there's a point which is 1. What's the midpoint between minus 1 and 1? So that's 0. And how do you get that? Minus 1 plus 1 over 2. So left point plus right point divide by 2. So that's how you get this. So on a midpoint, on a real line, it's easy to compute. So it's just a plus b over 2. Now we'll see even computing the midpoints in a plane. Like in a plane, you have situation like this, that somewhere we have another point, say one point x1 comma y1, and somewhere we have a point x2 comma y2. And you're interested in knowing what exactly is the point in the middle. What are the coordinates of the points in the middle? So we'll get a formula for that. So understanding analogously, so it's a plus b over 2. So here the coordinates of r are going to be, you do the same thing with this, but you have to do it twice. One for x coordinates and one time for y coordinates. So that's the coordinates of the midpoint. So here we have the formula m, standard notation for the midpoint, but you're free to choose your own notation, that's fine. It's x1 plus x2 over 2, y1 plus y2 over 2, because midpoint is a point, so it has to have 2 coordinates. So x coordinate is x1 plus x2 over 2 and y coordinate is y1 plus y2 over 2. This is how you depict it. So here we have an example. Find the midpoints of the line segment joining these 2 points. So P is negative 3, 6. If you compare that with x1, y1, so x1 is negative 3, y1 is 6. Q is 1, 4. If you compare that with x2, y2, x2 is 1, y2 is 4. So the midpoint is x, y, where x is x1 plus x2 over 2, y is y1 plus y2 over 2. So x1 is negative 3, x2 is 1 over 2, y1 is 6, y2 is 4 over 2. So negative 2 over 2, 10 over 2, so negative 1 comma 5. So I'll write here negative 1 comma 5. That's the midpoint of the line segment. This is also done here. The solution is also done here for the same question. Now for this also, I'll just give you one question for you to try yourself. You can pause the video and try this yourself. So midpoint is add the x values, divide by 2, add the y values, divide by 2. Like if you don't want to go into x1, y1, x2, y2 labeling and notations, you can just do it directly from the top of your head if you remember it that way. That okay, it's x values added, divide by 2, y values added, divide by 2. So 5 plus 6, 11 over 2, negative 3 over 2. No need to convert in points. You can leave it as such. All right. So the next thing we are going to talk about is what do we mean by graph of an equation? So you will be given some equation connecting two variables x and y, and then you probably wonder how does the graph of them looks like. So graph is a visual way of understanding the relationship between x and y, because when x and y are connected through an equation, they are affecting each other. That means if x changes, y changes. If x increases, y increases or decreases. If x decreases, y increases or decreases. So there are some effects playing along through that equation. So to understand those things going on visually, we need to draw the graphs. So graph is nothing but the graph of all ordered pairs in the coordinate plane that satisfy the equation. So how do you draw the graph of a given equation? You need to find various points, various ordered pairs which lie on that equation. What do you mean by lie on that equation? That means they should satisfy the equation. So if you collect those points which satisfy that equation, you collect them all, mark them into the plane and then join them, you'll get the graph. So we are going to see what does this mean through examples. So let's take a very simple example. Sketch the graph of the line y equals to 2x minus 1. So we have to make a list or a table of ordered pairs. So we need to have x and y values, and collectively we will look at them as ordered pairs. Now how we are going to generate these x and y values? So it's sufficient to plot like 5 to 6 points because you are just beginning, but later on we will realize this being a linear equation, it's actually sufficient to plot only 2 of them. But here we are just learning the process, so let's do at least 4 to 5 points. So choose some random x values. Like do not choose too high values or too small, just choose integer values for the beginning. Say x equals to 0, 1, 2, negative 1, negative 2, and try to choose both positives and negatives. Do not choose all positives and all negatives because then you will not be looking at the enough information. So I just choose these 5 random x values, and now y values are not random. They are controlled by this equation. So plug in all these x values one by one into the given equation y and then calculate y. So what is y when x equals to 0? So y is 2 times 0 minus 1. So 0 minus 1, which is minus 1. So that's how you get the y values. So x values were independently chosen, arbitrarily chosen, but y values are controlled by the equation given to you. So you compute that from that equation. What happens when x is 1? So it's 2 times 1 minus 1. 2 minus 1 is 1. So you get a 1. What happens when x is 2? So 2 times 2 minus 1, 4 minus 1, which is 3. What happens when x is minus 1? So I'm simply plugging in that value of x into the equation and solving it. Negative 2, negative 1, and x equals to minus 2. It is 2 times minus 2 minus 1. So minus 4 minus 1, that's negative 5. And now you have computed x and y values. Now write them as ordered pairs. And And it's not fixed that you have to have these ordered pairs only. You can have your own depending on what x you choose. So you'll get a different set of ordered pairs, but that's fine. We just need 5 to 6 points. And once you have these ordered pairs computed, then remember the exercise we did in the beginning. Take them and mark them in the plane. So I'm going to choose a scale. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then -1, -2, -3. -4, -5, and -1. Now mark these points. First point is 0, -1. So 0, x is 0 means it's a point on the y-axis at -1. So there's where you are. This is the point A. You don't need to use the labels, but I'm just showing you for the first example. 1, 1. This is where you are at, point B. 2, 3. So this is where you are at, C. -1, -3. So -1, -3. This is where are you? This is the point D. -2, -5. So this is where you are at, point E. So you mark them in the plane and then join them. Do not just leave them there, because this is not a graph. This is just a random collection of points. It will turn into a graph only when you join them with a line or a curve. Now, since this one, if you try to join them nicely, you will actually notice that they are forming a line, a straight line. So they have to lie on a line segment. So if you join them nicely, 1 second. Because I'm using this digital pen, my joining might not be very smooth, but if you do it on your notebook, be very careful. So you join them and clearly they all are lying on one line. So you will find all of them lying on the straight line. I'm not saying this is going to happen for every example, but this one specifically, because I know its type, I know by looking at the function that the graph is going to be a straight line. So that's what is going to happen. You'll understand this later. But here the purpose of this example was just to demonstrate the process for you. Join them smoothly, you'll get the graph. So you try that in Desmos, you'll be able to see that this is actually a line passing, not passing through region, but somewhere, and that's the equation. I hope the process is clear. Now we are going to apply the same process on a different equation. This time we have x squared minus 3. So I've already done the calculation here, so I'm just going to show you these points here. So normally I said you're supposed to take 5 to 6 points, but here we have like 7 points. So 3 negative x values, 1, 0, and then 3 positive. So I chose the value -3, -2, -1, 0, 1, 2, 3. And corresponding to these x values, you compute the y values by plugging them into the given equation. And then that's all done for you, and you can verify these calculations. So you get y is 6, 1, -2, -3, -2, 1, and 6 corresponding to those points. And collectively writing them as ordered pairs in this column, you'll get these. And now if you mark them, if you mark these points, so this is A, this is where you are at, -3, 6, -2, 1, that's the point, -1, -2, that's the point C, 0, -3, that's the point D, 1, -2, that's the point E, and 2, 1, that's the point F, and 3, 6, that's the point here. So if you join them smoothly, clearly they're not all lying on a straight line. They're lying in a specific position. Like if you mark them accurately, you won't be able to wrongly join them. So you would be obviously joining them smoothly. So it turns out to be a parabola if you do that exactly. Which kind of parabola? Vertically upwards parabola. And later on you will understand this, that it was supposed to be a parabola. That's for some equations, we can just tell by looking at the equation that, okay, what's the graph is going to be. Not every equation, but the linear one and the parabola, we do have a recognition of them. So here is where we are. And that's the steps we already demonstrated. So they are just summarized here. That step number 1 is making a representative table of solutions of the equation and then plot the solutions at ordered pairs and then connect the solutions with a smooth curve. Now you don't have to connect them with the non-smooth curves. What do you mean by smooth and non-smooth? Like if these are the points, so instead of connecting them like this, you're supposed to connect them smoothly. That's what we mean by smooth joining. The reasons for this, that why you have to connect them smoothly, that's a part of the calculus where you connect smoothness with a certain characteristic of the function. But here for the time being, you just assume you are connecting them smoothly, not sharply. So that's how you get the graph of any given equation. Now you can test this procedure on any given equation and you will see the graphs for yourself. And the good thing about graphs is once you draw them, you can go to this software, Desmos Graphing Calculator online, just input the equation and then verify the graph for you that, okay, what you have drawn is correct or not. So here's another example. You can try this yourself. I'm leaving this for you. And this is actually already done here. The solution is already here, so you can verify this later on. I took 5 points here, connects them, and it actually turns out to be parabola, but this time a downwards parabola. All right, the next thing we want to talk about, which is the last section of today, is intercepts. So what do we mean by intercepts? So now if you pay attention to these curves which you just draw, like this was a straight line, it's definitely meeting the x-axis somewhere. Like you can see, this is the point where it is meeting the x-axis. This is the line, sorry, this is the point where the line is intersecting the x-axis. So this point is known as x-intercept, and the point where the line is meeting the y-axis is known as y-intercept. And this was the parabola. So these 2 points are the x-intercepts because these are the intersection of the curve. Doesn't matter what type of curve it is, any curve, any line. If a curve is meeting the x-axis somewhere, those points are known as the x-intercepts. We can have more than one x-intercept as well. And this point in this case is the y-intercept because that's the intersection of the curve with the y-axis. So that's simple. The definition of x and y-intercept. So x-intercept is always going to look like a comma 0 because it's point on the x-axis, so its y value is going to be 0, and y-intercept is always going to look like 0 comma b because it's a point on the y-axis. So that's how the coordinates are. So these points where a given curve meets x-axis and y-axis respectively are known as x-intercepts and y-intercepts. Now the question is, if you've already drawn the graph, you can easily find them, but we need to have an algebraic way of computing x and y-intercepts. Like before drawing the graph, if you want to compute x-intercepts and y-intercepts, how do you do that? So it's easy. To find the x-intercepts, you put y equals to 0 in the given equation and solve that equation for x. Now why do you put y equals to 0? Because the x-intercept characteristic is that it's lying on the x-axis and the mathematical equation of the x-axis is y equals to 0. That's the reason. And similarly, to find y-intercept, you have to set x equals to 0. So easy. For finding x-intercept, put y 0. For finding y-intercept, set x equals to 0. So let's try this on an example. Find intercepts of y equals to 2x minus 4. So if you want to find x-intercept, put y equals to 0 in the given equation. So 0 is 2x minus 4. So this will bring you to an equation only in one variable, and you had learnt in the past that how to solve equations. So you can solve this one because this is linear equation, very easy to solve. So 2x minus 4 equals to 0 gives you 2x equals to 4, x equals to 2. So x equals to 2 is the x value. So 2 comma 0 is the x-intercept. And to find y-intercept, you have to put x equals to 0 in the given equation. So again, go back to the original equation, put x equals to 0. So you get y equals to minus 4. So if you write that as an ordered pair, this is 0 comma minus 4. So this is your y-intercept. Now what's the benefit of computing intercepts? Before drawing the graphs, if you compute intercepts, so it's like a good information for you. You will know exactly where the curve is going to pass on the y-axis and the x-axis, so your graph is going to be more accurate and precise. Other than this, there are more mathematical applications of finding intercepts, which you will learn later, but so far it's only for the purpose of drawing graphs. So this was an easy example. Let's try this on another example. Here we have a square function. So find x-intercept, put y equals to 0. So I told you, whenever you put y equals to 0, that will leave you an equation to solve for x. Now in the previous example, that was a linear equation, very easy to solve. Here you have a quadratic equation, again easy to solve. So for a quadratic equation, so solving a quadratic equation or find the solutions of a quadratic equation is an important skill. Everybody who is ever doing any subject of mathematics should be knowing how to solve a quadratic equation. You cannot just avoid it. You have to know it. So here I can use factorization, or you could use the discriminant formula, whatsoever works for you. So I'm going to do the factors. So x minus 2, x plus 1 equals to 0. So which gives me these 2 points, these 2 solutions. So eventually I get 2 x-intercepts, 2 comma 0 and negative 1 comma 0, because y had just one value 0, but there are 2 x values, give me 2 x-intercepts. So there could be more than 1 x-intercepts. And now to find y-intercept, you have to put x equals to 0 in the given equation. Y is negative 2. So 0 comma negative 2, that's the y-intercept. For most of the equations which are defined as functions, we'll see the functions later. So for them, we'll have one unique y-intercept and sometimes no y-intercept. But if there are x-intercepts, it could be 0, it could be more than 1 as well. So right now we're not deciding how many x-intercepts or how many y-intercepts are there. We're not going to guess that by looking at the equation. We just do the process and get whatever we get. All right, we're already done with this example. So that's all for this topic. So I'll meet you in the next video and continue from this point onwards. We'll talk more about graphs, talking about the symmetries, and then using the collective information to draw the graphs.